Okay, in this video we'll do two questions, finding the matrix of cofactors of A and the adjoint of A, and then we will use the formula how to find the inverse of a matrix of A, having the determinant of A and the adjoint of A. Okay, and these are connected. Okay, so let me just remind you what the cofactors were. If you have a matrix A, B, C, D, E, F, G, H, I, okay, and I want to find the cofactor of a particular matrix, let's call that, sorry, of a particular entry here, let's say the cofactors are 1, 1. Okay, what does that mean? That means that I have to evaluate the determinant of the submatrix obtained by erasing the first column and the first row, right? So erasing the first column and the first row. So the submatrix here is EFHI. But of course, don't forget to multiply that by -1 to power of what? Of the sum of these subscripts. So that's 1 plus 1. -1 to power 2 is just 1. So this is going to be equal to the determinant of EFHI. Okay? So that's going to be the cofactor when I have erased the first row and the first column. And then you have to do, for each entry, you have to calculate for each entry, you have to do this calculation, okay? Now, instead of going, because for our question that we're going to do, we'll find the matrix of cofactor. That means that we have to find all the cofactors. Instead of evaluating this -1 to depending whether it's even or odd cofactor, just remember that you can always put that the top leftmost entry is positive, and that every single consecutive entry, right, the sign will alternate. And similarly here, so negative, positive, -1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then here it's going to be positive, negative, positive, negative. So that way you can simply plug the number here, plug the sign, whether it's positive or negative, depending on its position in the matrix. Okay, so the first example is going to be finding the cofactor matrix of a 2 by 2 matrix. So let's say 3, 2, 1, 2, 3, 2, 1. Okay, so that means that we have to evaluate C1, 1. Well, first of all, always the top leftmost term, when I'm going to take out this term in order to calculate C1, 1, this is going to be positive, this is going to be negative, so this is going to be negative, this is going to be positive. Okay, so what will happen? I have to find the determinant of the submatrix when I'm going to take out the first row and the first column. Well, I'm left with only one entry, and the determinant of one entry is that entry itself. So it's positive 1. Now C1, 2, okay? First of all, that's this entry right here, so it has to be negative. Now I'm looking for the determinant of the submatrix taking out the first row and the second column. So that leaves me with the entry 2. Okay, then C21, right? C21, that's this entry. Obviously, the cofactor is multiplied by -1, right? So what will happen when I'm going to take out the column and the row where it belongs? That leaves me with the entry 3. Okay, and C22 is equal to, obviously here I have the positive, right? So that's positive. When I'm gonna take this row and this column, I'm left with the entry 2. So from here, the matrix of cofactors is simply 1, -2, -3, 2. So for a 2 by 2 matrix, this is very simple, okay? Things are becoming slightly more interesting because we are just having more calculation when we're talking about a 3 by 3 matrix. So let A be equal to the matrix 2, 3, negative 4, 0, negative 4, 2, 1, negative 1, 5. So first I'm going to find the matrix of cofactors. Then I'm going to evaluate the adjoint of A. And finally, using these results, I'm going to find what is A inverse. Okay, in order to find the matrix of cofactors, I have to go over every entry. So basically I'll have 9 cofactors, right? So again, remember that this is always positive, so the signs next are going to be negative. They're going to alternate, sorry. So positive, negative, positive, positive, negative, positive, negative, positive. Okay, so C11 is equal to positive, so I'm taking out the first column and the first row, is equal to the determinant of the matrix negative 4, 2, negative 1, 5. But this is a 2 by 2 matrix, so this is negative 20 plus 2, that's negative 18. Okay, now C12, sorry, so here it's C12, right? That's negative. So now I'm taking the first row and the second column, so that I'm gonna change the notation just to save some space here. That's the notation of the submatrix 0, 2, 1, 5. And again, I just multiply 0 times 5 to find a determinant of 2 matrix. That's 0 minus 2 with negative here, it's equal to 2. And C13, I'm taking out the first row and the third column, so that's positive. The determinant of 0, negative 4, 1, negative 1, and that gives me 0 minus minus 4, that's equal to 4. Okay, now C21 is going to be equal, so C21 is this term here, so I'm taking out this term. As you can see in front of it, I have minus, so minus the determinant. When I take out the second row and first column, I'm left with the submatrix 3, negative 4, negative 1, 5, and that's equal to 15 minus 4 is 11 with negative in front and negative 11. C22, first of all, it's positive, so plus. The determinant of the submatrix when I'm taking the second row and the second column, so second row and second column, leaves me with 2, negative 4, 1, 5, and that's 10 minus negative 4 is 14. And C23 is negative times the determinant of the submatrix obtained when I'm taking out the second column and the third row. That's 2, 3, 1, negative 1. 2, 3, 1, negative 1. And this is negative 2 minus 3 is negative 5 with negative in front, that's equal to 5. Okay? And in a similar way, you're going to find the cofactors of the last row there. So C31 is equal to negative 10, C32 is equal to negative 4, and C33 is equal to negative 8. So the answer to question A, what is the matrix of cofactors? That's just this, negative 18, 2, 4, negative 11, 14, 5, negative 10, negative 4, negative 8. Okay? Now B. The adjoint of A is equal to the matrix of the cofactors transposed. So that's transposed, okay? So that means that you will find the adjoint of A, okay, by finding the transpose of this matrix. So that's very easy. That's negative. So switch the rows and the columns. Negative 18, negative 11, negative 10. The first column becomes the first row. The second column becomes the second row because we're looking for the transpose. 14 and negative 4. And the last one is 4, 5, and negative 8. Okay. Sorry about that. And the last thing that you have to do is use this you have to use the adjoint of A to find A inverse. And this is a very important formula that you have to know. Okay, the relation between the adjoint and the inverse. So A inverse is equal to 1 over the determinant of A times the adjoint of A. So if you find the determinant of this matrix, let's do it. So let's find the determinant. So I can do this by doing the cofactor expansion about the second row. So that's 0. Then you have negative 4 times 2 negative 4, 2 negative 4, 1, 5, positive minus 2 times, okay, 2, 3, 1, negative 1, 2, 3, 1, negative 1. But don't forget that we have already evaluated those, right here. So that's negative 4 times 14 minus 2 times 5 is negative 56, if I'm not mistaken, minus 10, that's negative 66. So once you have the determinant of A, then A inverse is simply negative 1 over 66 times the adjoint of A, negative 18, negative 11, negative 10, 2, 14, negative 4, 4, 5,